Assalamualaikum warahmatullahi wabarakatuh and greetings to all AP students. Alright, so it's so sad that we need to meet online for the last topic of the hydrocarbon compounds due to the public holiday today. But it's okay. I hope you can understand what do I give to you for today's lecture because it is very light compared to the previous lecture that we have discussed in face-to-face class, which is about the mechanism of direction. Okay, today we have no mechanism. It's just a normal direction equation to be discussed over here, right? So this is the 10th lecture. Okay, lecture yang ke-10 yang terakhir dah. Okay, tomorrow you will meet Dr. Liu Yi for the aromatic compounds. Alright. So the first reaction that we want to discuss is about the hydroxylation. Okay, actually today we want to discuss about the three types of the oxidation reaction. Okay, before this we have discussed about the addition reaction of the alkene, and today we discuss about the oxidation reaction, and the first oxidation reaction is the hydroxylation. So for this reaction we use the potassium permanganate as the reagent. Okay, potassium permanganate is the oxidizing agent, the famous oxidizing agent. Okay, beside the KMnO4 we also can use the K2Cr2O7, or we call it as the potassium dichromate. Okay, and this potassium permanganate can undergo the reaction in two different conditions. The first one is dilute potassium permanganate at room temperature or in the cold condition of the reaction. We call it as the hydroxylation. Okay, and the second one, we can also undergo the reaction by using the concentrated potassium permanganate with heat. Okay, the hot potassium permanganate. Okay, we heat the reaction. So the oxidation of the alkene will undergo the oxidative cleavage, where the C double bond C, the double bond will break into two parts. Okay, and you replace by the oxygen. Okay, C double bond O. Okay, will give two different products for the acyclic, but as for the cyclic, it will give just a single product as well. Okay, so the hydroxylation is added to OH group. Okay, kumpulan hydroxy to the C double bond C. So we have C double bond C. So you need to add the OH over here, OH over here. So you remove this double bond, okay, to be the single bond. And the addition of these hydroxyl groups in the syn manner. So you still remember, right, about the halogenation, the addition of the halogen, which is C double bond C, addition of the halogen, which is Cl and Cl, for example, in the anti manner. Okay, anti-addition. But in this case, the addition of the hydroxyl group in the syn manner. Alright, the syn addition. Okay, so as for the syn and anti-addition, for the acyclic structure, for your level, it is not that important. Okay, we can assume that the product is still the same. Okay, just assume it's the same, but it's actually not exactly the same product. Okay, the syn and the anti-addition will give the different product actually. All right, but for the addition of the anti and the syn addition to the cyclic compound, it will give the cis and trans structure. Okay, cis and trans structure. The anti will give the trans structure, while the syn addition will give the cis structure. Alright, so this type of addition just important for the cyclic ring at your level. Okay, for the acyclic ring is we just assume that the product is the same. Okay, So the reaction undergo in the basic solution. So you need to put the KOH, for example, or NaOH. Okay. And the reaction will decolorize the purple color of the potassium permanganate. Okay. Warna ungu potassium permanganate itu akan decolorize to form the colorless solution. Alright. And also you can see the formation of the brown precipitate, which is formation of the MnO2. Okay. Therefore, the permanganate or the manganese itself, okay, reduced from the Mn7 plus actually in the potassium permanganate, okay, reduced to Mn4 plus in the manganese dioxide. Okay. So since the potassium permanganate undergo reduction, therefore our organic compound, which is the alkene, undergo the oxidation. So this is some sort of the redox reaction. So oxidation from the alkene to form the diol. Okay, this is what we call as the diol. Alright. So the nice color test for the double bond functional group is known as the Bayer's test. So tindak balas ni kita panggil juga sebagai the Bayer's test. Okay, nama dia adalah Bayer's test. This is one of the unsaturation test beside the bromine test or the bromination test. Alright. So kita recap balik lah. Sebelum ni we have discussed about the bromination, isn't it? Alright. For example, if you have the cycloalkane and you have the cycloalkene. Alright. So you react with the bromine. Okay. In CCl4, for example. Okay, the inert solvent. Okay, we can't use the polar solvent such as water because the product is different. Okay, we have discussed if you put the water in the bromination of the alkene, we will form the halohydrine. Okay, so we use the inert solvent, which is the CCl4, and remember this reaction must undergo in the dark. Okay, mesti dalam keadaan gelap. Okay, dark condition. Okay, sebab apa must in the dark condition? Because kalau in the presence of the UV light, okay, haloalkane ataupun haloalkane pula, alkane and the cycloalkane will undergo substitution reaction, which is the free radical substitution. So the observation will be the same as the alkene. So kita tak naklah observation dia sama, kita nak observation yang berbeza. So we need to proceed the experiment in the dark. Therefore, for the cycloalkane will have no reaction. Okay, kalau no reaction, what is the observation? Okay, we can see that the brown color, okay, brown color of the bromine solution will remain, okay, remain as it is. Okay, meaning that tak ada reaction berlaku lah kalau warna coklat bagi bromine solution tu kekal. But for the bromination of the alkene, okay, it will produce the dihalide. Okay, and the addition is the anti-fashion. So the anti-manner will produce the trans product, which is Br, and this Br satu ke depan satu ke belakang, which is the trans product. Okay, so this is colorless. Alright. So kalau kita tak tahu unknown yang diberikan kepada kita, which one is the alkene, which one is the alkene, kita boleh tambahkan sahaja bromine. But remember, you must undergo the reaction in the dark, dalam keadaan gelap. Okay, so that one of the unknown jadi colorless and the other one akan remain the brown color of the bromine solution. So yang remain is the alkane, and the decolorize of the brown color of the bromine tu is the alkene. Okay, ini satu unsaturation test. Alright, dan yang kedua yang kita baru bincang sebentar tadi is the hydroxylation or the Baeyer test. So sama juga. Alright, so cycloalkane react with the KMnO4, okay, dan medium dia ada base OH minus dan mesti dijalankan pada keadaan sejuk, cold, ataupun room temperature pun boleh juga. So this has no reaction. Okay, bila no reaction, what is the observation that we can see? That the purple color of potassium permanganate will remain. Okay, remain purple color, purple solution. Alright, but as for the cycloalkene, when you react with the same reagent, okay, KMnO4, okay, OH minus, and cold condition. Okay, you react dengan keadaan yang exactly the same, just beza dia pada double bond. Okay, you will produce the diol, and this diol, okay, the addition of the diol in the syn manner, which is produce the cis diol. Okay, the cis diol. Alright. And also the potassium permanganate will reduce to form the manganese oxide MnO2. So the diol itself is the colorless. Colorless. Alright. So you can see the purple color decolorized to the colorless solution and formation of the brown precipitate. Alright, the MnO2 is the brown precipitate. Alright, so this is shown by this diagram lah. Alright, so you masukkan this purple solution of the potassium permanganate, alright, into this compound. Kita tak tahu compound ni compound apa. This is an unknown, okay, unknown compound. Alright, so if the color remain purple like this, okay, remain, meaning that it is maybe the alkane. Okay, no double bond or triple bond present in the unknown compound. Okay, but if you see the purple color decolorized, become the colorless solution. Okay, and formation of the brown precipitate. Okay, this is brown sludge dia tulis kat situ, samalah. Okay, tak kisah, brown precipitate pun okay. Alright, so actually the compound has the double bond, okay, which is the alkene lah in this case. Okay, so ini cara macam mana kita nak bezakan between the alkene and the alkene, okay, by using the potassium permanganate. Dan selain potassium permanganate tadi saya dah bagi tahu, we can use also the bromine solution. Alright, itu the first reaction. Okay, the first oxidation reaction yang kita nak discuss pada hari ini. Alright, next. Okay, oxidative cleavage by using KMnO4. So tadi hydroxylation kita guna KMnO4 juga. Alright, and this time kita nak buat oxidative cleavage juga menggunakan KMnO4. But what is the difference between these two? Okay, this time the KMnO4 you need to use the hot concentrated KMnO4. So kalau tadi dilute, okay, yang tadi dilute, yang ni hot. Kalau yang tadi cold, silap. Yang tadi dilute, this one is concentrated. Kalau yang tadi cold, this one is hot, KMnO4. So bila dia panas, what happen? Dia akan potong C double bond C. Okay, C double bond C. This bond will break and replaced by the oxygen. And it depend on what is the atom attached to this C. Okay, kalau dia ada RR, maka dia akan hasilkan C double bond O R R. Okay, kalau dia ada RH, asalnya dia akan hasilkan C double bond O H R. Asalnya macam tu. But since potassium permanganate is a strong oxidizing agent, so this H, okay, can undergo further oxidation, okay, to become OH. So dia akan jadi C double bond O, OH, R, which is formation of the carboxylic acid. Okay, carboxylic acid. This one is the ketone. Alright, so aldehyde dia tak terbentuk. Okay, dia hanya macam intermediate sahaja sekejap, and then further oxidation to become the carboxylic acid. And how about if the C, okay, kat sini, let's say dia ada H, kedua-dua H. So sama juga, initially dia akan bentuk C double bond O, H. And the further oxidation of this compound ni kita panggil sebagai methanol. Alright, the further oxidation of the methanol will produce the carbon dioxide and water molecule. Alright. Okay. Itu ada satu persamaan yang saya, okay, so saya terpaksa padam balik all these drawing. Okay. But actually it is similar to what I have explained to you before. Okay. So if you can see in this example, okay, or in this equation, alright. So on the right side we have C double bond RR. So it will produce C double bond O R R. Okay. This is the product on the right side. Okay. And for the left side, we have C double bond HR. Okay. So akan hasilkan this product C double bond O HR. But okay, this aldehyde can undergo further oxidation. Okay, undergo further oxidation. I'm sorry. To produce this carboxylic acid. Okay, carboxylic acid. Cumanya kat sini dia tak tunjuk kalau CHH. Okay, for example, if you have CH2 double bond CH2. Okay, so bila putus kat sini, it will produce carbon dioxide and water. Okay, and since you have two CH2 over here, CH2 on the left, CH2 on the right, so you will produce two carbon dioxide and two water molecule. Alright? Okay, next. Oxidation by KMnO4. Okay, tadi kita dah bincang. Okay, by hot concentrated KMnO4, you will produce the oxidative cleavage product. Alright. And the cold dilute KMnO4, you will produce the diol. Okay, which is hydroxylation. Alright. So, for example, okay, contohlah, kita bagi beberapa contoh. If you have this, alright. So, in cold and dilute KMnO4. Okay, hot and concentrated KMnO4. Cold and dilute will produce OH, okay, which is diol in the syn manner. So OH masuk pada tempat yang sama, dua-dua ke atas ataupun dua-dua ke bawah, doesn't matter. Alright, but for the oxidative cleavage, you will break this bond. Okay, here you have one H, so this H will oxidize to OH. Alright, so you will get, sini akan oxidize pada OH, dan sini double bond akan jadi O. So you will get the carboxylic acid. Okay, dua carboxylic acid. Okay, kenapa dua? Because this is a symmetrical punya compound. Okay, this is symmetrical punya compound. Okay, but okay, kita tukar. instead of but2-in, kita tukar pada but1-in. Alright, but1-in. So sama juga, kalau in cold dilute KMnO4, you akan dapat OH, okay, the diol in the syn manner. But hot concentrated, okay, you will break this bond, okay. So over here you akan dapat double bond O. Sini sebenarnya ada H, so akan jadi OH. Okay, H akan jadi OH. So carboxylic acid. And for this side, okay, ini sebenarnya CH2. Okay, CH2. So CH2 will oxidize kepada carbon dioxide and also water molecule. Okay, dan kalau kita ubah lagi, okay, tak ada tempat nak lukis, so saya padam yang atas. Okay, saya ubah sikit sahaja, di mana this side saya letakkan metal. Okay, saya letakkan metal. So on the left kita akan dapat, okay, untuk hydroxylation sama je. Okay, hydroxylation kita akan dapat OH. Okay, maksudnya kita tambah je OH on the same side, okay, the syn manner. Okay, but for the oxidative cleavage, okay, on the left side kita akan dapat C double bond O, sini H jadi OH, right? This H jadi OH. And for the right side, okay, for the right side kita akan dapat O, which is the ketone. Okay, yang ni tak boleh berubah. Okay, sebab dia the highest oxidation state. Ketone akan jadi ketone juga. Okay, aldehyde akan jadi carboxylic acid ataupun carbon dioxide and water. Okay, depends on how many hydrogen that the carbon have. Alright. Next. Okay, itu tentang reaction kedua. Okay, reaction ketiga is the ozonolysis. This one is almost similar as the second reaction. Okay, which is oxidative cleavage by the hot concentrated KMnO4, but the difference is the product do not undergo further oxidation. Okay, for example, you can see in this equation when you cleave this bond. Okay, so RCH over here will remain as it is. So RCH kekal, cuma you putuskan the double bond and you replace by the oxygen atom. Alright, so dia kekal macam tu, which is the aldehyde. Tadi kalau you ingat, okay, by using the hot concentrated KMnO4, H ni dia tukar kepada OH. Sekarang ni dia tak tukar, dia kekal macam tu. So lagi senang lah. Okay, it's easier than the previous reaction. Okay, and as for the right side, okay, sini Cr2, okay. So dia akan kekal lah Cr2, okay, with the C double bond O. Okay, this is the ketone. Alright. So dekat sini ada juga saya tunjuk contoh for the cyclic ring. Okay, if you cleave the cyclic ring, dia tak akan dapat dua produk sebab the molecule is still intact. Okay, masih lagi bersama. Alright. So you just cleave the ring. Instead of the cyclic, you dapat acyclic structure. So if you use the ozonolysis punya reagent, so you akan dapat diol. Okay, let's say this is carbon number 1, 2, 3, 4, 5, 6. So this carbon 1, 2, 3, 4, 5, 6. Okay, so tempat dia putus tu kita letakkan C double bond O. Okay, and then dekat setiap carbon ni ada satu H pada C double bond tu. So this H ni kekal as it is. Alright, and pada CC yang lain tu dia ada dua H, so kekal as it is. Alright, but if you use the hot concentrated potassium permanganate, okay, so kita tulis KMnO4 concentrated. in the hydroxide, and then second we acidify balik and we heat. Okay, so step number 1 ada 3 lah, concentrated KMnO4, OH minus and heat, and step number 2 we acidify balik, okay, untuk dapatkan the acid structure tu. So the product is almost the same as this one, okay, but the difference is, remember the H will convert to OH, so dia akan jadi HO dekat sini, and this guy pun jadi OH. So, akan dapat dicarboxylic acid. Alright. So, kita tengoklah perbezaan dia. Okay, sama juga. Okay, for example, if you have H2C double bond CH2. Okay, when you break this bond, kalau hot concentrated KMnO4, okay, hot concentrated KMnO4, it will produce 2 carbon dioxide and 2 water molecule. But by using the ozonolysis, okay, ozonolysis, you will produce H2C double bond O. Okay, ini ada 2. Sebab yang satu lagi tu is O double bond CH2. Okay, sama je lah 2 ni. Okay, sama. So, kita lukis satu sahaja. Alright, kita letakkan nombor 2. Okay. Ini for the primary lah. Okay, for the secondary. Okay, for example, this one tadi. Okay, butane. Okay, so kalau KMnO4, hot concentrated KMnO4, it will produce OH, ada 2. Tapi by using the ozonolysis, you akan dapat OH, ada 2 juga. Kenapa 2? Because this is a symmetrical molecule. Putus kat sini, putus kat the left side of the molecule and the right side of the molecule is the same. Alright, so dihasilkan 2 dicarboxylic acid or 2 carboxylic acid ataupun 2 aldehyde. Alright. Next, kalau unsymmetrical molecule, okay, let's say but1-in tadi. Okay, but1-in, when you break this bond, so on the left side, untuk KMnO4 dulu, KMnO4 on the left side, you akan dapat OH. On the right side, KMnO4, you akan dapat CO2 and water. So, these are the 3 products of the oxidative cleavage by using hot concentrated KMnO4. But if you use the ozonolysis reagent, okay, on the left side, you will get OH, which is the aldehyde, and for the right side you will get C double bond O H2. You akan dapat aldehyde. Okay, so this is aldehyde, this is also aldehyde. Alright, but for the hot concentrated KMnO4, you akan dapat carboxylic acid, okay, carbon dioxide and water. Okay, and if you have tertiary carbon, okay, saya padam yang atas Alright, okay, kita ambil sama je molekul like this. Okay, the tertiary carbon. Okay, so on the left side, okay, when you break this bond, okay, by using the hot concentrated potassium permanganate, you akan dapat the ketone. Okay, the ketone. On the right side tu carbon dioxide and water, samalah. Sebab saya tak ubah on the right side tu. Okay, saya just ubah on the left side. So, saya akan dapat ketone instead of the carboxylic acid tadi. Alright, and for the left side, kita akan dapat carbon dioxide and water. Okay, but by using the ozonolysis, okay, on the left side, you dapat ketone juga. And the right side, you dapat methanol. Okay, CHO lah. CH2O lah saya tulis. Okay, methanol boleh juga tulis macam ni. Okay, instead of like this. Okay, ni dalam bentuk structure. This one dalam bentuk formula. Alright, so you can see here, the ozonolysis and the oxidative cleavage by using hot concentrated KMnO4 will produce the same product, okay, on the left side, okay, which is the ketone. Kenapa? Because the ketone is the highest oxidation state. Okay, so ketone dah tak boleh lakukan further oxidation, so dia punya produk akan sama lah. Okay, tapi kalau aldehyde ataupun methanol, the product is different. So you can see lah more example over here. Okay, so you tengok kat sini, you have one hydrogen, okay, on the right. So by using the ozonolysis reagent, you will produce this is as the aldehyde. Alright, and on the left, okay, since this is the tertiary carbon, okay, yang saya kuningkan kat sini ni tertiary carbon, so tertiary carbon will produce the ketone. Okay, so ketone tak boleh lakukan further oxidation. Dan kalau kita bandingkan dengan KMnO4, so kat sini tak lengkap ni, kena tulis lagi dia punya reagent. This is concentrated KMnO4, the hydroxide ion and also heat. Okay, kena ada lengkap, 3 barulah cukup syarat dia. Dan step nombor 2 kena ada acid. Okay, so ada 4 lah, termasuk acid tu ada 4 semua. Alright, so on the right, on the left side, okay, it will produce the same compound as the ozonolysis, which is the ketone. Okay, sama sahaja. Alright, but on the right side, okay, ini tak sama. Okay, ozonolysis produce the aldehyde, but for the potassium permanganate, it will produce the carboxylic acid. Okay, more example. Okay, more example. Okay, you can see over here, you have 2 hydrogen. Okay, sebelah kiri tu samalah, so kita tak bincang lah sebelah kiri tu, sebelah kanan ni. You have 2 hydrogen, so you will produce the methanol. Okay, this is the methanol. Alright, but as for the hot concentrated KMnO4, sama juga tak lengkap ni. Concentrated hydroxide ion and segitiga, which is the heat. Okay, kena cukup lengkap 3 ni, dan yang proses yang kedua adalah acidified. It will produce carbon dioxide as the main product. Selain daripada carbon dioxide, yang saya tertinggal kat situ is the water, ataupun mungkin terlindung ni. Alright, is the water molecule. Alright, so just a simple lecture for today. I hope you can understand about this. And if you have any question, apa-apa soalan berkenaan dengan hydrocarbon compound ni, don't hesitate to meet me lah, jumpa saya, it's okay. Okay, especially bila time dah tak ada lab tu, I'm quite free to entertain the student. Alright, so I hope you can understand all of this topic and you can answer the test and also the examination very good. Alright, excellent. Okay, so di kesempatan ni saya saya mengambil kesempatan lah untuk memohon kemaafan sekiranya ada sebarang kekurangan sepanjang pengajaran saya untuk 10 tajuk lecture ni. Okay, 7 kita bincang face to face and another 3 we just discuss through this video. Okay, segala kesilapan Saya mohon maaf lah kalau ada salah dan silap tu, dan saya halalkan segala ilmu yang telah saya berikan kepada anda semua, dan saya doakan anda semua selamat maju jaya. Sekian, terima kasih.